Okay, picture this. You walk up to your absolute favorite houseplant, just eager to check on its new growth. And instead, you find it looking totally sad, wilted, or discolored. Your heart kind of drops, right? And your immediate thought is probably panic. You're wondering who or what is responsible for this. Well, welcome to this explainer. Today, we're going to treat your garden and your living room like a botanical whodunit. We're officially strapping on our detective hats to investigate the plant crime scene. So, when we see a plant struggling, our very first instinct is almost always to blame ourselves. We instantly think, oh, great, I watered it too much, or I didn't water it enough, or I stuck it in the wrong window. But hey, before you go on a guilt trip over your gardening habits, it is entirely possible that a tiny intruder might be the actual culprit. Plants, especially the ones inside our homes, can easily become victims to pests that just multiply like crazy in those comfortable, completely predator-free environments. Let's clear something up right off the bat by separating the actual living suspects from the environmental red herrings. In plant diagnostics, we divide problems into two broad categories, biotic and abiotic. Biotic factors are the living organisms. We're talking insects, fungi, bacteria, viruses, the things actively attacking your plant. Abiotic factors, on the other hand, are the non-living stressors. Think sudden temperature drops, terrible soil drainage, or chemical burns. It is absolutely crucial to rule out those abiotic factors first. I mean, you definitely don't want to accidentally treat a poor drainage problem by spraying pesticides all over your kitchen. All right, moving to Section 1, Signs versus Symptoms. Gathering evidence. Just like any good detective, we have to learn how to read the clues left behind by our suspects. And the big takeaway here is understanding the difference between a sign and a symptom. A symptom is basically just how your plant reacts to being attacked. Wilting, yellowing leaves, stunted growth, these are symptoms. They scream, hey, something is wrong, but they don't necessarily tell you what caused it. A sign, however, that's the physical, visible evidence left by the pest itself. Egg masses, fungal spores, or the actual bugs themselves. Finding a sign is your golden ticket to solving the mystery. Look at this. This brilliantly illustrates a sign in action. See that molted skin left behind by a sawfly right there on the leaf? As insects grow, a lot of them shed their exoskeletons. Finding cast skins like this, or egg cases, or even, bug poop, is indisputable physical evidence of an intruder. It's literally the equivalent of finding a fingerprint at the scene of the crime. We can actually compile these clues into a forensic evidence table. This helps you match physical residues to the usual suspects. For instance, if you spot large green or black pellets, that's frass, which is essentially insect poop, and that points straight to caterpillars or beetles. A sticky, glistening coating, that's honeydew, which is often followed by a gross, black, dusty fungal layer called sooty mold. Fine silken threads point to spider mites, while those translucent whitish husks we just talked about are cast skins from things like aphids or leafhoppers. Okay, prepare to be a little grossed out, but look closely at how one of these signs is actually produced. This is a macro shot of an aphid actively excreting a drop of honeydew. These little guys suck so much sugary sap out of the plant that they literally have to excrete the excess. This sticky honeydew coats the leaves below and then acts as this perfect breeding ground for that dark, ugly, sooty mold we just mentioned. It is a complete chain reaction of plant damage. Section 2. The suspect lineup. Chewing versus sucking insects. Now that we know how to spot the evidence, we can divide our prime suspects into two very distinct groups based on how they feed: chewing insects and sucking insects. Chewing insects, like beetles and caterpillars, cause really obvious mechanical damage. I mean, they take actual physical bites out of your plant, leaving behind holes and large frass. Sucking insects, though, they are way more stealthy. Pests like aphids, whiteflies, thrips, and mites have these needle-like mouthparts called stylets. They pierce the plant tissue and just drink the sap, which leads to those subtle but devastating symptoms like leaf distortion, stippling, and just a general loss of vitality. Check out this visual comparison of the two crime scenes. On the left, we've got a pepper plant totally infested with aphids. Notice how the damage isn't big, gaping holes. Instead, the plant is just covered in tiny bugs, sticky honeydew, and the leaves look all puckered and distorted as the sap gets drained out. Contrast that with the right side, where you see the incredibly obvious, totally destructive nesting of chewing caterpillars in a web. They're literally stripping the foliage away bite by bite. We also absolutely have to highlight one very specific, incredibly common indoor suspect, the spider mite. Now, fun fact, Spider mites aren't even true insects. They're arachnids. But man, are they notorious sap-suckers. Because they are practically microscopic, you very rarely see the mites themselves. Instead, you'll see this, unmistakable fine webbing draped across the stems and leaves. And it's usually accompanied by foliage that looks all dusty and bronzed because they're literally draining the chlorophyll from individual plant cells. Another major suspect in the sucking category you really need to keep an eye out for is the whitefly. These pests are super tricky because the adults look like tiny, delicate white moths. The immature nymphs just stay glued to the underside of the leaves sucking sap, but the adults give themselves away instantly. If you gently bump or disturb an infested plant, the adults will suddenly flutter off in this tiny, chaotic white cloud. It is a dead giveaway. And then we have mealybugs. Watch out for these guys. They are the absolute masters of disguise in the plant world. They're these small, soft-bodied insects, but they cover themselves in a fluffy, white, waxy layer. So to the untrained eye, an infestation just looks like little tufts of cotton or lint stuck right in those tight crevices where the leaves attach to the stem. But do not be fooled. Beneath that cottony armor, they are steadily draining your plant's life force. All right, section 3, the motive and opportunity, the disease triangle. So, we know our suspects, and we know their methods. But to truly crack the case, we have to step back and ask, what specific conditions are actually required for a pest to successfully establish a full-blown infestation? You see, pests don't just magically appear out of nowhere and destroy a perfectly healthy, resilient plant. It turns out the stars really have to align for the bugs to win. And this brings us to one of the single most powerful concepts in plant health, the disease triangle. For any successful attack to happen, 3 things must be present at the exact same time. First, you need a susceptible host, so a plant that is already vulnerable or stressed. Second, you obviously need the actual pathogen or pest to be physically present. And third, you need a favorable environment. Things like high humidity, poor airflow, or incorrect temperatures that basically act as an all-you-can-eat buffet and breeding ground for the pest. I absolutely love this quote, because it is essentially your secret weapon. If any one side of the triangle is missing or weak, the disease cannot fully develop. Make sense? Remember, as the manager of your plant's ecosystem, you actually have the power to alter the environment. Breaking just one side of this triangle, whether that's giving the plant more light, reducing the humidity, or just choosing a hardier plant variety to begin with, that is your ultimate defense mechanism. Which leads us to section 4, the master plan, Integrated Pest Management. So how do we put all of this awesome detective work into action? Think of IPM as the holistic justice system for saving your plant and maintaining order in your living room. Integrated pest management is an ecosystem-based strategy. It focuses on identifying this specific problem, figuring out what your tolerance for it is, and then actively managing the environment. It's all about playing the long game. It is the exact opposite of panicking and just immediately nuking your plant with harsh chemical sprays the second you spot a yellow leaf. This strategy actually builds a literal hierarchy of defense. IPM starts way down at the foundation with host selection, meaning picking plants that actually naturally thrive in your specific environment. Then we move up a level to cultural management, which is adjusting things like your watering schedule or your soil mix. Next up is biological management, which is super cool. That's using natural predators to do the dirty work for you. And only at the very, very top of the pyramid do we even consider chemical management. Let's make this super concrete with some highly practical, non-chemical interventions you can literally do today. If you see caterpillars or beetles, just handpick them off and drop them into some soapy water. Boom, done. If you have leafhoppers or maybe a light aphid infestation, honestly, you can often just spray them right off the plant with a strong jet of water. You can tweak your watering schedules so the soil isn't a damp breeding ground for fungus gnats. You can even buy and introduce beneficial predators to hunt down the bad bugs for you. Now, I really need to emphasize this point. Reaching for chemical pesticides should truly, truly be your absolute last resort. And this is especially true for houseplants because they live right next to us in our indoor living and working spaces. Using chemical sprays indoors can be difficult, it can be messy, and it's generally just undesirable for the health of the humans and the pets sharing that environment. Well, we have covered a lot of ground in this explainer, from spotting the tiny physical clues left by intruders to understanding the broader environmental factors that basically roll out the red carpet for them. So I'm going to leave you with this final challenge. The next time a leaf drops or a stem wilts, will you just blindly treat the symptom? Or are you going to use your new detective skills to uncover the microscopic ecosystem battling right beneath your nose? Thanks for hanging out with me, and happy sleuthing.